The Ficep Orient 11 CNC drilling line represents one of the most innovative new lines from Ficep in recent years. This system incorporates a single high-performance CNC-controlled spindle that articulates automatically to process all three surfaces on structural steel shapes. This simplistic approach reduces the required mechanical and electrical components by 2/3 when compared to typical 3-spindle drilling lines. The project is carried out using 3D CAD system, which Ficep has been employing for many years. Beatties are made of strong steel plates and are mass-produced. They are specifically designed to tolerate the drilling stress. Let's take a closer look as to why this model is rapidly becoming the first choice of many fabricators around the world. A powerful material positioning system secures and advances the section for processing. The material positioning and measuring carriage utilizes a precision dual rack and pinion system to position and measure the section. The roller ways allow the pincher to transfer also flat bars. The pincher can be oriented in order to clamp either profile flanges and web. As the section advances to the drill, the material length is automatically measured and the location of the leading end is established. Once the leading end of the section enters the line, the non-datum clamps adjust automatically to the section size that is to be processed. Independent vertical and horizontal roller clamps secure the section during drilling and positioning. The Orient 11 features a high-performance drill head with an articulating spindle that can be rotated a full 180 degrees in less than 1 second to accommodate processing of both flanges and the web with just one high-performance drill head. The massive drill head that is central to the design of the Orient 11 features a ball screw precision feed to utilize today's high-performance tooling, such as carbide inserts, in a most productive fashion. These carbide tools feature drill penetration rates that exceed those of tools with high-speed inserts by 4 to 5 times. The high rate of feed, in conjunction with the spindle drive that develops 2,500 RPMs, reduces the required tool pressure and generates small drill chips rather than long spirals that are so typical when drilling structural steel with twist drills. A lineal tool change rail with just a simple in and out motion makes automatic tool changing extremely reliable. Once a tool is selected for the first time, a laser measures the tool length and automatically enters the data into the CNC control without operator involvement. Up to 6 different tools can be accommodated on the Orient 11. When more tools are required, up to 12 tools can be furnished as an option. The automatic tool changer, in conjunction with the positive ball screw feed of the drilling head, not only provides for high-performance drilling, but also countersinking, tapping, and milling, which is ideal to accommodate those requirements for slotted holes. Orient spindle is designed for tools' internal and external lubrication cooling. The CNC control tracks tool wear to determine even when it is time to automatically change to a second tool of the same diameter, for example. Additional manual layout is totally eliminated with the scribing capability that can perform part marking, layout lines or welding symbols on 3 surfaces with the scribing tool in conjunction with the Ficep software. This capability can also be furnished for the underside of the web. The y-axis positioning speed of the drill head is 30 meters per minute or 98 feet per minute to minimize process times. The massive drill head is guided with dual prismatic ways to achieve maximum stability. Lubrication of all critical points on the Orient 11 is accomplished with an automatic centralized lubrication system. The Orient 11 can be furnished with a CNC-controlled Ficep engineered and manufactured bandsaw to function as an automated fabrication cell. The same CNC control that operates the drill also controls all functions of the sawing process. All CNC-controlled motions of the saw's clamps, guides and the feeding of the head are guided with prismatic ways. The adjustable blade guide moves to the optimum location based upon the depth of the section to be cut, as commanded by the CNC program. The saw can pivot up to a maximum of 60 degrees in either direction automatically by program command. All miter adjustments are accomplished with an enclosed rack and pinion system in conjunction with a servo-controlled axis. Once in position, it is locked hydraulically for subsequent cutting. The independent dual horizontal material clamps engage the material automatically. Two vertical hold-downs sliding on linear guides automatically clamp the profile once it is in the working position. The software recognizes the section that is being processed and rapidly advances the blade to the start position, which is just above the top of the flange. As the blade contacts the top of the flange, the feed rate is reduced until the blade is fully engaged in the material. The rate of feed increases until the blade contacts the web surface, where it is reduced due to the larger cross-section. After the web is cut, the feed rate returns to a more aggressive rate to finish the sawing process. With the completion of the cut, the gap between the finished part and the stock length is automatically increased to facilitate the withdrawal of the blade without contacting the material. As the blade exits the cut, a non-ferrous motorized brush rotates to disengage any chips that remain in the blade. The sawing unit can be equipped with an automatic swarfs conveyor. The CNC control, in conjunction with our proprietary software, performs such additional functions as providing an automatic blade conditioning cycle after the installation of a new blade and advising the operator when it is time to change the blade. When cutting deeper sections, stresses that are resident in the section from the rolling process can pinch the blade when cutting the web. The Ficep CNC-controlled saw employs an oscillation cycle in these cases to utilize the set of teeth in the blade to increase the kerf of the cut to reduce the potential of pinching the blade. The sawing base is made of wear-resistant material. A variable speed drive motor in conjunction with the gearbox delivers both the optimum speed and torque to the blade. The Ficep CNC drill lines, in conjunction with a Ficep engineered and manufactured bandsaw located after the drill, offers a fabricator the most productive and automated system available today in the marketplace. The combination of a carriage feed on the entry side for feeding material through the drill and then to the saw offers unparalleled automation. Regardless if 2 or 200 parts are processed from a mult, the operator only depresses the cycle start once, as all subsequent functions are fully automatic. This, in conjunction with the ability of the Ficep drill saw tandem systems multitasking software to achieve the ability to drill and saw simultaneously, are just a few reasons why Ficep is considered today's world leader in integrated systems technology. Isn't it time to learn more about how Ficep can enhance the competitiveness of your firm in today's market? Give us a call to find out more about the extensive line of over 65 different CNC systems from Ficep.